Okay, we have seen what is Z statistic or Z test. Then after that, we have just seen the hypothesis testing. And now we will be deep diving into one-way test or one-tailed test or two-way test or two-tailed test. Because to understand these hypothesis testing and their respective tests well, you need to know about minimum one statistic. Any one statistic you should know. So here, as we have seen what is Z statistic or Z test, now it's pretty easy for you to understand and make some sense out of the one-way test and two-way test. That's the reason. First, after completion of Z test, we have come to the one-way test and two-way test. So let's begin. So hypothesis tests are classified as either one-tailed, also called one-sided or one-way tests, or two-tailed, also called two-sided or two-way tests. So one-tailed test, one-tailed tests are concerned with one side of a statistic, such as the mean is greater than 10 or the mean is less than 10. Thus, one-tailed tests deal with only one tail of the distribution, and the z-score is on only one side of the statistic. On another side, two-tailed test deals with both tails of the distribution, and the z-score is on both sides of the statistic. For example, a hypothesis like the mean is not equal to 10 involves a two-tailed test, because the claim is that the mean can be less than 10 or it can be greater than 10. So now let's look into a table where you can find critical z-score for one-tailed and two-tailed with respect to various levels of significance. So let's look into it. So the top row that we see is a level of significance. We have 0.05 level of significance, 0.01, and it further reduces down to 0.05 and 0.02, and even it can be increased up to 0.10, just 10 percentage. From 10 percentage, 5 percentage, 1 percentage, 0.5 percentage, and 0.2 percentage, and this is the level of significance. Various levels of significance as we use it for various purposes. Okay, first let's see various critical z-scores or critical values for various levels of significance for one-tailed test, specifically for one-tailed test. If you see one-tailed test for level of significance of 10 percentage, it is 1.28. If it is a left-tailed test, it's minus 1.28. If it is a right tail test, it's 1.28. And similarly, the most important level of significance that widely used by data scientists was 5 percentage. So the critical score, the critical value for 5 percentage of level of significance is 1.645. If it is left-tailed, minus 1.645. If it is a right-tailed, again, it depends upon what type of test you are doing. It's left-tail or right-tail. So then we have two-tailed tests, and two-tailed tests, their obviously, as we have discussed earlier, one tail tests deals with only one tail of the distribution. But when it comes to two tail test, it's going to deal with both tails of the distribution, and that's what you see on the screen here. So here it's, if you take 5% of level of significance, it's left of minus 1.96 and it's right of 1.96. These two regions will be considered, and even if you take 10% left of minus 1.64, the left region of minus 1.645 and complete right region of 1.645. Anyway, that visualization of these critical values of respective levels of significance will also be seen in forthcoming slides. Okay, in a one-tailed test, the area under the rejection region is equal to the level of significance alpha. Also, the rejection region can be below, that's left of the acceptance region, or beyond, that's to the right of the acceptance region, depending on how alternate hypothesis is formulated. When the rejection region is below the acceptance region, we say that it is a left tail test. You can see here it's a left tail test. In left tail test, this is how we formulate the hypothesis that you can see here on this, on your screen. One tail test, and specifically it's left tailed. Obviously your null hypothesis would be mu x is equals to mu naught, whereas your alternate hypothesis is mu x is less than mu 0. Then it's called left tail. If you say something would be lesser than, anyway, we're taking up the example. If you take a simple example, if you say your life of the light bulb is 2 months. Let's take 2 months. That is your null hypothesis. Then in one tail test, alternate hypothesis is it would be less than 2 months. That's it. Simple. The average life of light bulb will be lesser than null hypothesized mean, which is 200. It would be less than 200. That is what is our alternate. To this kind of situation, we will work with left tail test, and this is your rejection region. Okay. Then on the other side, when the rejection region is above the acceptance region, or right side of the acceptance region, we say that it's a right tail test. Here you can see that right tail test, or same example. Let's take the life of the light bulb, and null hypothesis, it's equal to 2 months. And if your alternate hypothesis is the average life of light bulb will be greater than 2 months, then we have to use a right tail test. And here is that the rejection region is right side of the acceptance region. And if you want to see the values, and here you can see for left tail test with a level of significance 0.05, for the left tail test it's minus 1.645, whereas right tail test it's just 1.645. It will come here. Exactly, it will come here. We'll take up only this section from 0, 1, 2, 3. So it will come here exactly 1.645. Okay. That's how left tail and right tail works. Then In a two-tailed test, there are two critical regions, and the area under each region is alpha divided by 2. As stated earlier, the two-tailed test is consists of two regions, one beyond the acceptance region and one after the one left side of the acceptance region, other one is right side of the acceptance region, and that you can clearly see on the screen here. Okay, so our two-tailed test would be formulated in this way. You can see that here, a two-tailed test. As usual, the same example you can say, life of a light bulb is 2 months is our null hypothesis, and alternate hypothesis, it is not 2 months. That's it. It could be lesser than 2 months or it could be greater than 2 months, but we are not worried about that. It's just not 2 months, and that's what we call it as a two-tailed test. And this two-tailed test will be widely used in data science to understand, to find out the statistical significance of two of two variables. Okay, so that's what is two-tailed test. Note that in a one-tailed test, the alternate hypothesis involves that involves values that are greater than mu x. We have a right tail test. Similarly, we have a left tail test. For example, let's take a simple example. For example, an alternative hypothesis on the type alternate hypothesis HA mu x greater than 100 is a right tail test, while an alternative hypothesis of the type HA mu x less than 100 is a left tail test. So this table summarizes different types of tests in the figure. So mu naught is the current value of the parameter or null hypothesis. Okay, so that's what is the difference between one-tailed, two-tailed test, and specifically left tail and right tail test. Next, we will be deep diving into one test.